Hello, geometry team, and welcome to the second part of our review walkthrough here. I am on problem number 32 right now. And so for problem number 32, we're needing to go and find the diameter of a hemisphere when you have the volume as 4601.39. And so if we recall, the formula for the volume of a hemisphere is going to be 2/3 pi r cubed. And instead of knowing the radius or diameter, we know the volume. So that's what we're going to plug into our formula. We're going to take this 4601.39 and say that's equal to 2/3 of pi r cubed, whatever that is. And so then we just work our way backward. So to get rid of the 2/3, I'm going to multiply by 3/2 because that's the inverse. But if I do it on the right, I'm going to do it on the left. So now I have them both. Actually, if I do it on the right, do it on the left. Mrs. Cerna can talk. And so those will cancel and those will cancel, and I'm left with pi r cubed here. And over on this side, I've got 6902 point something like 09, something like that, okay? And then you go, all right, I want to isolate my radius so that I can find my diameter. So I'll divide by pi on both sides, and that will give my radius cubed. And this is going to end up being pretty close to 2197 exactly when all the decimals work their way out. Then to get the radius on its own, I need to do the cube root of r cubed. And if I cube root one side, I need to cube root the other. Okay? And so the cube root of 2197 is going to be, I'm going to come into my calculator here. If you have an iPhone, it's honestly just on your iPhone calculator. If you set it to the side, your cube root is right here next to your square root. It's got the little tiny 3. If you're in your TI calculator, to do this, you're going to go into your math button, and on that menu, you're going to have cube root down here. And so you'll hit that, and it's going to pull up cube root of whatever, and I want the cube root of 2197. Now I accidentally hit parentheses, and I don't know why. And so when I do the cube root of 2197, I'm going to get 13 is my radius. Well, I didn't want my radius. I wanted the diameter. And so my diameter will be twice that, which is 26, and then that will be meters since my volume was in meters cubed. Okay. Turning over now. The Luxor Hotel in Las Vegas is a square-based pyramid that's 646 feet wide at the base. So this is 646 feet along here. And since it's square, this will also be 646 feet. And 350 feet tall, which as we know, height is going to be perpendicular from the top down to the middle here. And that will be 350 feet tall. If the outer walls of the hotel are covered in glass, what is the minimum amount of glass? Well, if I'm covering outer walls, this is going to be surface area. And so to find the surface area, I'm going to need to do the lateral surface area. I don't want the total surface area because that would include the base. I don't need to put glass on the base. I just need to do the outer walls. So I'm going to be doing the lateral surface area of my pyramid, which will be 1/2 perimeter times slant height. And so I go, okay, I need 1/2. The perimeter of my base is going to be this 646 times 4 to get all the way around. And so that's going to give me, 646 times 4 comes out to be 2584. And then I need my slant height. And I look, I don't have slant height. And so I'm going to have to calculate a slant height of this pyramid. Well, to do that, I'm going to need to make a right triangle. And so for this right triangle, I know it's 350 feet tall right there. But this base right here, I'm going to need to go, okay, it's halfway across my square, so it will be half of the 646, which will be 323 feet across. So now I can use my Pythagorean theorem to find this pink slant height. So I'm going to say, okay, I'm going to have a squared, so 350 squared plus 323 squared equals c squared, whatever that is. And so that's some big old numbers. You put them in your calculator and you come out with 226,829 is my c squared. And so then to get just that slant height, I'm going to square root that. And my c comes out to be something like 476.3-ish for that slant height. And so that's the slant height I need in my formula. So I'm going to come over here and go, okay, this is my slant height, so 467.3. And that's now in my lateral area formula. So my lateral area is going to come out to be, working all this out in my calculator, 615,340.84. And since it's an area, it will be square feet. So square feet for the amount of glass used to cover the exterior. That, my friends, is a lot of glass covering a hotel. This is why buildings cost millions and millions of dollars to make. Now, our newest step, changing dimensions. I'm going to start off telling you that the volume of a cylinder is 97 cubic feet. And I'm going to double every dimension. So this is going to be a similar shape. And since I'm doubling every dimension, I'm going to need to take whatever my, I just lost the word. My scale factor is and cube it. Okay, so my original scale factor, I'm doubling everything. So my original scale factor is to take everything and multiply it times 2. But to get my new volume scale factor, I need to take that 2 and cube it. And so I'm going to need to multiply everything by 8 for my new volume. So my original volume was 97. And then to get my new volume, I multiply by my volume ratio. And that's going to come out to be 776 cubic feet for my new volume. For a triangular pyramid, my surface area is 1936. And I'm going to take all my dimensions, so this is a similar shape, and I'm going to multiply it by 1/4. So my original linear scale factor was 1/4. So my surface area scale factor is going to take that 1/4 and I'm going to square it. So my scale factor for surface area is 1/16. So I'm going to take my original surface area, 1936, and I'm going to multiply it by 1/16 to get my new surface area. And that new surface area is going to be 121, and it'll be millimeters squared. Number 40. I have a first solid with this big old volume and a second solid with a little bitty volume. And I want to know how many times larger solid A is than solid B. And so I'm going to think, okay, I've got 5632 for my original big volume, and solid B has a volume of 11. And so when I simplify this down, this comes out to be 512 to 1. So it is 512 times bigger. But this is my volume scale factor. So my volume is always my original scale factor cubed. And so my volume scale factor is 512 is something cubed. And so to find that original scale factor, I'm going to cube root 512 to get back to my original linear scale factor. And when I do the cube root of 512, my scale factor comes out to be 8. And so my big volume is going to tell me that my solid A is 8 times larger than solid B, because my scale factor was 8. How many times larger is the volume of a cylinder if the radius is multiplied by 5? And so my volume of a cylinder formula is going to be pi r squared times height. And so I go, okay, My radius is multiplied by 5. So my scale factor was 5. But I need to do a volume scale factor. And so I'm going to need to take 5 and raise it to some power up here. So I'm going to see how often that radius is used in my formula. And my radius gets squared. It's multiplied twice. So I'm going to take my original scale factor and raise it to the power of 2. So my volume scale factor is actually going to be 25. So my bigger volume is now 25 times larger than the original. Now, going smaller. I've got the surface area of a sphere. So for my surface area formula, I know that's 4 pi r squared. And I'm going to take that radius and multiply it by 1/3. So my scale factor is timesing by 1/3. So my surface area scale factor, or my surface area ratio, I'm going to have to take that 1/3, and again, I need to raise it to some power. So let's see how often that radius gets used in my surface area formula. Well, in my surface area formula, my radius is multiplied twice. So I'm going to raise this to the power of 2. And so my new surface area is going to be 1/9 the original. So it's 9 times smaller. Whatever that denominator is tells you how many times smaller it is since it got smaller. Thank you guys. Good luck and have a great time on the test.